My project called Smart Investment. The reason I'm doing this project is because nowadays more and more people start their stock investment, but the price of stock always changing. So our simulation provides people a good way to predict the stock price in the future based on the past data. Monte Carlo simulation is to generate a large number of random samples from a specific probability distribution or a group of probability distribution to reflect the impact of system risk. So this is the formula of Monte Carlo simulation. From the formula, we can see Monte Carlo simulation believes that stock price fluctuation can be divided into two parts. The first part is drift, which means the stock will fluctuate according to the rate of return. And the second part is shock, which is a random fluctuation. So our Monte Carlo simulation in our code is we are providing 100 simulation and keep predicting for 30 days. So we can see from the graph each line represents one simulation. From the plot, we can see the progress achieved in each simulation is different, but most of them are concentrated in the middle. And if we try to plot the distribution of the final stock price and compare with the real data, and this is the figure, we can see the blue line represent the simulation value, and the orange one is the original data. We can see our Monte Carlo prediction model can give us decent shape for forecasting stock price. But in the real scenario, people won't only buy one stock for investment purpose. When investing in stocks, people always buy a few more to resist the risk. So for enhancement of the model, we use Markovo's portfolio optimization combined with Monte Carlo simulation. So yeah, this is the formula of Markovo's portfolio optimization. So from the figure, we can see the axis represent the returns and y-axis represent the risk. The green line here means efficient frontier. Efficient frontier is a set of optimal portfolios that offer the highest expected return for the defined level of risk or the lowest risk for a given level of expected return. So we build the portfolio with the stock of following 9 major companies, which is showing in the table here. So in the real situation, people need to decide how to allocate their funds. Means which company they want to buy more stocks, which company they want to buy less stocks. This requires setting corresponding weights for them. So below we will use three-weight distribution schema to calculate the investment income under the different combination. So the first solution is to set a set of weight in advance. The weight we set for those 9 companies are showing in this table. If we do a accumulated for for the weight column, we will get 1 in total. So if we apply the portfolio, Markowitz portfolio model into the first solution, we will get a portfolio return over time by those two graphs. The first one means returns every day, and if we do a accumulated daily income, we can get a figure below this one. Now we can get a curve of accumulated daily income in a good shape. So the second solution is to set the equal weight of those 9 companies, and we apply the same simulation in second scenario. We can get the orange line here. The blue line is first solution, and the orange line is second solution. We can see there's not a lot of different. They are relatively close, which indicating that the weight of first schema does not have many advantages compared with the equal weight. Then we need to find a better one portfolio. So in third solution, we consider the market value of the company and assign the weight based on the proportion of the market value. The market value column is here. And then we apply the Markowitz portfolio model into the third scenario. We can get the green line here. If we compare with those three scenarios, the green curve in this figure represents a portfolio weight by market capitalization, which is performed significantly better than the first two options. Also, we can get the correlation and the covariance between all stocks in heat map and matrix. So we can see those heat map are showing the correlation between those 9 companies. The data in dialog is 1, which means one company is totally related to itself. That is why the data in the dialog is 1. And then we can introduce the Monte Carlo simulation into our portfolio. So because the next thing we need to consider is which combination weight should be selected is the best. So we randomly generate a set of weight, calculate the returns and the standard deviation of the combination, and repeat this process as 10,000 times. Then we get this graph. Then we highlight the point with the least risk in the return risk scatter chart, which is this red point. And we draw the cumulative yield curve of the minimum risk portfolio, which is this green line. If we compare with the other curves above, then we can see even though the return is not higher than the other situation, but which is pretty reasonable because people's perception of relative low returns on investment with small risk. So now we finish our simulation, and this research has achieved the goal of practical application of the Markov's model to establish the optimal investment portfolio. And by investing in an effective investment portfolio, um, which is which give people a prediction for their future investment. Thank you. Finished.